Okay, so let's talk about conversions. Okay, even though that we like to think of conversions as just like inches to feet or centimeters to miles, the way that we would do this is we are still comparing two units, so we're still going to make our proportion table. Okay, there has to be a proportional relationship there uh, to begin with, which is our conversion, and then we're using that to scale up to the missing amount. Okay, so if I read this question, Chris bought 10.4 gallons of gasoline. There are approximately 3.8 liters in 1 gallon. Which measurement is closest to the number of liters of gasoline Chris bought? So when I'm looking at this, sometimes what we want to do is we want to take this first bit of information here and we want to put it on this side, okay? But we have a full and complete rate or ratio right here. And that's what is going to go in the first column, okay? So this one is going to be, we'll have liters over gallons and liters over gallons. I'll kind of spell it out a little bit. So 3.8 to 1. And then the other bit of information that I have is we want to know how many liters if I have 10.4 gallons. So sometimes conversions can be a little bit more tricky because you, like I said before, you want to take the first information that they gave and put it in the first column. But that's not necessarily true. What you want to find first is the rate of which the conversion is. So here we have 3.8 liters in 1 gallon. So there's your 2 units. There's your original conversion. All right. So now what I'm doing is I'm scaling that rate to however amount that I need. So originally we had 1 gallon. Now I want to know for 10.4 gallons. All right. So the scale, my scale factor, well, 1 times what is 10.4? 10.4. All right. So then what I'm going to do to solve this is 10.4 times 3.8. I'm just checking this in the calculator because we got some decimals in there. It's a little bit scary. And I'm getting 39.54. Okay. Now, I'm weird. I like to just kind of double check that I didn't accidentally type this in incorrectly, that I did what I was supposed to. Okay, we're good. All right, so if I have 10.4 gallons, I also, that same amount, equivalently, have 39.54 liters. Okay, and so there's our answer right there. All right, so let's look at the next one. The distance between two towns is 120 kilometers. There are approximately 8 kilometers and 5 miles. You see how that second sentence has both units? So that is going to be our rate right there. That is our ratio. For every 8 kilometers, it's equivalent to 5 miles, okay? So the two things that we're talking about here is kilometers and miles. Okay, if you don't know the fancy smancy abbreviation for these, don't worry. You could do K&M, kilometers and miles. Okay, if you know the abbreviation, then that's fine. If not, then just use the letters. And make it easy for yourself, okay? If they have the same letters, then kind of either spell it out a little bit more or whatever that you need to do so that you can distinctively tell the difference between your two units. All right, so I'm going to use the second sentence because that was the one that had my full rate in there. So 8 kilometers, 5 miles, okay? And then over here, the distance between two towns is 120 kilometers. That's going to go on the kilometers part right there. All right, so either that you right off the bat know what 8 times what equals 120, then that would be really easy, but most of us probably don't know that right off the top of our head. So we're going to use our formula for scale factor, which is new over original. Okay, and so that would be 120 over 8, and then we would start simplifying. Maybe start with 4, maybe 2, whatever that you're comfortable with. If you want to at this point, if you don't think it's going to be a decimal, you're more than welcome just to pop that into the calculator. So this would be 30 over 2, and we know that 30 divided by 2 is 15. So our scale factor right here is 15. We, of course, could have just done 120 divided by 8, but just so that you can kind of see where this stuff is developing. So now we're going to do 5 times 15, 5 times that scale factor, to get how many miles? So 75 right there. Okay, so 120 kilometers is about 75 miles. Cool. All right, Chloe is 5 feet 4 inches tall. There are 2.54 centimeters in 1 inch. What is Chloe's height in inches? Okay, so I threw this one in here because it does kind of have a little bit of an extra step for us. Okay, I'm going to have to, but I don't want to have to make 2 tables here. There should be kind of a little bit of an easier conversion that we can hit on the head, but maybe we want to make that table. So what I want to do is convert first 5 feet into inches. Okay, and so I'm going to develop this. I didn't mean to spell inches that way. Tried to fix it and I messed it up more. Okay, so we're going to kind of develop this thought process, and I'll show you how this works if I'm building this table again and using that information. So old, scale factor, and new. All right, so the 2 things that we're going to have here is feet and inches, and to be honest with you, it doesn't matter which one's on top and it doesn't matter which one is on the bottom. The only thing that matters is if I have feet over here on top, then I need to have feet over here on top as well. Okay, so do we know how many feet or how many inches make a foot, or vice versa? There's quite a few different ways that we could approach this. Okay, some people, you know, what I know and what I remember from my conversion table or a quick search on Google is that if I have 12 inches, that is equivalent to 1 foot. Okay, and so I'm going to use this information to figure out how many inches are in 5 feet, so that I can then use that information into the original problem or the next step of the problem that we're trying to solve. Okay, so kind of the same jazz here. 1 times what equals 5? Okay, 1 times whatever this number is equals 5. Well, 1 times 5 equals 5, right? So what does 12 times 5 equal? 60. Okay, so what I have right here, and I'm going to go back to this problem, is instead of the 5 feet, I'm going to say 60 inches plus this 4 inches here. Okay, so now the only units that I'm farting with up here are inches and centimeters. Okay, here's my original ratio that I'll use for this conversion. So cannot spell, centimeters and inches. Okay, so 2.54 centimeters, 1 inch. And then we will do centimeters on top again, inches on the bottom. Well, the total number of inches that Chloe is 64. Okay, so now when I'm looking at this one is not that bad. Even though that it was a 2-stepper, even though I had to go over and convert feet into inches. And the reason why I was saying that some of us don't have to make a table for that is some of us know that it's times 12 going from feet to inches. Some of us know that, some of us don't. Some of us aren't sure if we need to multiply or divide. And so that's why making that table for most of us is very beneficial, so that we can make sure that we are solving the problem correctly. All right, so again, same idea here. Okay, 1, because this is the one that I'm looking at. I don't have anything here to say 2.54 times what equals what. I have 2 unknowns, and so that is not going to help me. I just want 1 unknown, work to find that one, and then I'm going to use that to solve for the x. Okay, and so this top row isn't going to help me much if I go there, but this bottom row, 1 times what equals 64? 64. So now I can say 2.54 times 64 is 162.56 centimeters. Okay, and there's our answer on that one. Okay, so hopefully this helps. I just want you to hopefully see that even though that I have shown you all of these different, and I'm saying it loosely, types of problems, they are all ratios, they're all rates, and we are using proportion tables to find the unknown. Okay, and so you are setting them up. I'm being as consistent as possible. My scale factor formula does not change. My missing or my variable always goes in the new column, and I am working left to right, and I'm checking my work and using my table. Okay, so there's no reason why that we should be using another process to solve this. Use what is here because it's going to work on all of those problems.